In fit bias, we will talk about today how we can make bias DC analysis for fit. It's almost like BGT, but fit different than BGT. That in fit we are using voltage control. In BGT we are using current control. So this is the difference between fit and BGT. How we can use this one? Here some major some excuse me. Here we have in difference between or a formula that we used for fit. First one, Ig equal 0, Id equal Is. This is for all. For MOSFET and for GFET and MOSFET depletion, we have this formula Id equal IDSS 1 minus VGS over VB squared. For MOSFET enhancement, Id equal K. I said to you how we can calculate K VGS minus VT squared. So, and as you know, until now, we use those in just for the transistor. How we can put this transistor, how we can find the bias for transistor, working point for the transistor. This is our job today. First configuration for today called fixed bias configuration. It's like BGT, exactly like BGT. Here we have RG. Here we have VGG in minus, RV, and here we have VDD, VO, VI. As we said before, if we have DC and AC, we are using here superposition method. That means we are using, first of all, or we will calculate for DC, then we will calculate to the AC. So now I will ignore AC and I will work for DC. Capacitor for DC is open circuit, so we'll cancel the capacitor. See, this is the circuit. This is the circuit. And here we don't have RG because IG is 0. So RG here is also nothing, so we can ignore it. So let's make Kirchhoff for the circuit. So from Kirchhoff, VG equal minus VG. In exam, you have to just calculate, use this. Okay, let's remember what we said before in VGT. I will write here again. First of all, calculate in VGT we said IB. We calculate VGS. 2 draw transfer curve. This is in fit. I'm going to comparison. For BGT, if you remember, 1, calculate input current like IE or IB. Then find relationship between input and output. We have two formulas for this. IC equal beta IB, IC equal alpha IF. Remember. Then 3, calculate output voltage. Here same thing, but we don't have this formula. So draw transfer curve 3 from transfer curve find working point. 4, find from transfer curve output voltage. This is the steps. So now we'll calculate VGS from input. Circuit. Let's start with this. This is the steps to fit DC. This is, we said this is VGT DC. Okay. Now, this is VG here, or VGS equal minus VGG. Now, I want to draw. So this is draw. This is draw in table. You have to find. This is table 6.1 in chapter 6. We need 4 points, 1, 2, 3, 4 to draw this curve. Hujam, where's VB and IDSS? I given here in the question. I will give you in the question IDSS and VB. After that, I want to find where is working point. So VGS equal minus VGG. And here is VG is a number, constant number, 5 volt, 6 volt, 7 volt. So it's like this. From that transfer curve, we will find VG is equal minus VGG. Then after that, this point is Q point or working point. I will find ID. Is to clear this idea, the steps? Is to clear how I find it? Okay. After that, now this is Ahmed. Instead of using in BGT we said IC equal beta IB, but here we don't have beta. So now we have ID. After that, you can calculate output voltage. So because it's nonlinear, we are using curve. That's the idea why we are using curve, because it's nonlinear system. It's nonlinear system. We are using curve. Okay. After that, you can calculate the output VDS equal VDD minus IDRS. VDS here, if you remember, it's like VCE. And the same formula, VCE, we said, equal VCC minus ICRC. So it's like BGT. Got it? Any question for this? Example. Determine the following for the network. I have 1 mega as RG, 2 volt, 2 kilo, and IDS is given, VB is given. VB is minus, so this is G fit in channel. First of all, you have to remember the name of this. What's the name? What's the name? I forget. Let's return back and see the name of this configuration. Fixed bias. It's like fixed bias in BGT. So today almost same. VGSQ is minus VGG. It's 2 volt directly. You have to know the formulas. After that, in this question here, they solve it based on math. Hojam, math is easier than graph. Yes, but just here it's easier. Later will be hard. So I prefer to use graphical approach. Okay, here they find the IDQ, then they can find the values. In exam, you have to, or you must use graph. You must use a graph. You have to draw this transfer curve and find from transfer curve the value. Hujam, there is a little bit shift between each student. يعني a little bit. For example, here IDQ it's 5.6. So if it's 5 point, for example, 5, I will accept. 5.4, I will accept. Not 5.5 and by 5.7. That's mean 1 milli before, 1 milli after. We can accept this one because it's a graph. Clear? For example, it is 4. No, I will not accept. 3, I will not accept. So, excuse me, practice transfer curve by your hand. Try to draw many times transfer curve to avoid any problem for the transfer curve. Now, after that, you can calculate the formulas. Any question for this? Same thing. So, can we use math? Yes, but I will not accept because math is just accept easy here in this case because VGS is a number. But later we see that we are for VGS we have formula, so it will be hard. So we're gonna use graphic approach. Any question for first one? Ahmed? Another one now, or self-bias configuration. In self-bias configuration, see the I will compare. Here we have 1 mega and we have 2 volt. But here we don't have volt, we have RG. Fixed bias, self-bias. Fixed bias, we have RG here. Power. Here we don't have. But we have here RS. So how we can calculate, this is the configuration after omitting the capacitor. So we have here, but where's RG? Again, RG cancelled because we have RG is really big, so we can't see RG nothing, 0. Just we have now this. This resistor can make bias for transistor. This one. And we can say also IC equal ID. If you remember, we said sometimes it's IC equal IE in BGT. Here, same thing. We can say I source equal I drain in FIT. Okay. From the input, you can find that Kirchhoff, and you can write VGS is minus IDRS. Minus IDRS. This is the input. It's important. This is your okay. This is what you have to study in exam. Oh. Important. You shouldn't do this. Just to calculate this. Continue. You have to draw the transfer curve. Hojam, why you said we shouldn't use mathematical? Because if I take this VGS and put in the formula, see, Ahmed, we have here ID here and ID here. So I should calculate 2 and take out and calculate. Then we get this formula. Then you have to calculate. A little bit will be hard. Got? For that, I said to you, we have to use a graphical approach. Is easier than mathematical approach. Got the idea why I said to use graphical approach? Because for this reason. So for this reason, graphical approach will be easier than mathematical approach. Any question for this? So let's go now to graphical approach and see how we can draw this one. This is transfer curve. Any question for transfer curve? Any question we have, I will give you IDSS and VB. So you have to draw from table 6-4. Now, how we can draw this one? Which one? This one. Okay, I will write here and draw by myself. We found VGS equal minus IDRS. VGS. So here we have VGS, we have ID. So I want to draw. This is, by the way, this is equation or formula for degree 1. That's mean it is line. So for this one, we have 2 points. I need 2 points. First point is 0, 0, this point. Second point, I will select ID مثلا equal IDSS, then VGS equal here minus IDSS RS. It says select here. I don't know where is the var VGS مثلا here, another VGS. Here. Then you can make a line. This is IDQ, and this is VGSQ. Got it? Selecting point. Selecting point. Let's see in your book. I will select مثلا here VGS equal minus the IDSS over RS 2. Here he selected IDSS 2. For me, I can select IDSS. Then you can find another point. Then you draw line. This line pass through or cross with transfer curve in a point is called Q point. And you can find IDQ VGSQ. Clear, Ahmed? Clear, anyone? Muhammad? Jalal? No. Good morning, Ariane. How are you? Okay. See, after that, you can calculate VDS from the output circuit here. Here, if you remember, we did same thing for BGT. We have this output, so it is minus VDD positive ID RD positive RS positive VDS equals 0. Here we said ID equal IS. Can accept this. Then you can calculate VDS is VDD minus ID RD plus RS. Is it clear? I guess this is from BGT, so it's easy for you also. Now, determine the following for the network of figure 7.12. VGSQ, IDQ, here the problem. He gives to me IDSS 8 millivolt, VB 6 volts, so you know, VGS minus IDRS, IRS is 1 kilo ohm. So you have to calculate, then draw the curve. Here he flipped, this one, forget this. You have to draw this. Fine, he selected the point. You can select any point you want. For example, you can select IDSS 2, over 2 IDSS. Then you can find VGS and 2 points. So what he said to us, if we happen to choose ID equal 8 milliampere. So in here he choose milliampere, make a line with another point. See, the VGS should be minus 8 volt. Choose. Calculate. So I have here VGS equal minus I DRS minus 8 milliampere. RD, for example, 1 kilo. This with this. So VGS equal 1 volt. So now I have a beer. What the beer is? VGS is 1 volt, comma 10 or 8 milliampere. This is point, this point I need. I have 0, 0, make a line cross with. I draw this, for example, this is Q, IDQ, VGSQ. I got easy, not hard. This is the second one. You can calculate after that from the graph here. IDQ is 2.6 milliampere. VGSQ is minus 2.6. Then you can find the rest of the value. Now, here we have a question, Ahmed, Ariane, everyone. Find the cosine point for network F. In this formula, as you see, we have VGS equal minus IDRS. RS, if you remember, it's like RE. Okay, let's return back to that BGT, and we said RE is the most important resistance, because when you said that the stability for BGT, we find that when this RE can mix, or the most important resistance for stability. Same thing here. Now here I have a question. Find the cosine point for network if RS 100 ohm, RS 10 kilo. Now we have three values for RS. What are those? I have RS 100 ohm. I have RS 1 kilo ohm. I have RS 100 kilo. I calculated for this. So if I decrease or increase, what will happen? We draw a line. What will happen for this line? Now we study this line, and what is the importance for this line? Keep this value with us. Now, first of all, RS 100 ohm. And RS 10 kilo ohm. So if I draw the graph or the line, just a minute, I want to check about this one. See this one. This RS 100. This RS 10 kilo ohm. And this is my RS. Don't forget. This is RS 1 kilo. So as you see here, if I RS decrease, I will go to the y-axis. RS, so RS just a minute. RS decreases. RS increase, I will go to x-axis. So what that's mean? That's mean, take care for this. There is limit for RS. If I increase, for example, RS to be 1 mega ohm, maybe my line will be out here. So this is not working. Why not working? Because it is, this is our working area, this area. But here I am out of working. Got it? So you have to take care about the value. As you see, normally we are using 1 kilo ohm. But if I increase or decrease this than this value, maybe this cannot work. Just a minute. Wait. Okay, I did mistake. Just a minute. Here, not decrease. Here, decrease. Okay, you have, okay, maximum value here will be the 0. Okay, so we will see this later. Also, if increase, that's mean this area. For example, we can see this line or this move, or this line move here. That's mean ID here is again not working. ID equal 0, also not working. Or if I decrease, it will be this case. So VGS equal 0, ID equal ID is so also not working. So you have to select RS to be in the middle, not up not less, not more. So usually the optimal value is 1 kilo ohm. This is what you can say cosine for this RC. Any question for this? In practical note, how a lower level of RS bring the load line of the network closer to the IID axis, where increasing value of RS bring the load line closer to the VGS value, and that's what I said. So you have to work in the middle. You have to select 1 kilo. Now, third case is voltage divider bias. Same thing for BGT. If you're with me in BGT, it will be here easy for you. This is the second. In BGT, if you remember, we studied what we can say Thevenin. We found free Thevenin, R Thevenin, and. Here, let's check this configuration. Oh, same thing. So here also you have to calculate Thevenin. This VG is V Thevenin. RT VCC over R1 plus RT. This is in BGT. So same thing here. So what we said for BGT still correct here for voltage. Still correct. So VG here is R2 VDD over R1 R2. Then you have to calculate V Thevenin and calculate the values. Okay. Now, if I make this, I want to ask myself, how can I draw the load line? Let's check. Okay. VG minus VGS minus VRS equals 0. VGS equal VG minus RS. Okay, this is the value. VGS equal VG. This is the VG. See, this is the circuit here. This is VG here. Or VThevenin. This is my circuit here. It's not so clear. Okay, equivalent for this one. If you remember, we have VG or VThevenin. Then after that, we made transistor, VDD, RD, RS, and here we have R7, sure. Did you remember this? Okay, let's continue. Here, as VGS is VG minus ID RS. Here you can see from this Kirchhoff VG is minus VGS minus RS. VGS equal VGG minus VRS. Hujam, where is VThevenin? We cancelled. Why? Because we said input volt is 0, so we cancelled RThevenin. So we have this formula VGS equal VG minus ID RS. So if it's remember now the values, fixed VGS equal minus VGG, self bias VGS equal minus ID RS. See, here we have voltage. We have this formula. VGS equal VGG minus ID RS. So every time we will add component, this is the new component here. It's VG minus ID RS. Now again, I want to draw this selecting 2 points. How we can selecting those 2 points? First of all, I will select selecting 2 points. I need to select 2 points. I will write the formula here. VGS equal VG minus ID RS. So if I select ID equal 0. So VGS equal VG. This is the point. Now, another point, if I select, I need this point, any point, for example, if I select VG equal 0, this point, or sorry, VGS equal 0, sorry, VGS equal 0, second, this is the first point, the second, I need 2 points at this point. So here, VG equal IDRS, ID here equal VG over RS. Then you can find this point, then make a line. Is it clear? Then cross with transfer curve gives to me Q point. So a trick here, how you draw transfer curve and how you select the points that you need to draw the load line. So here we have two figures. First one is how to draw the transfer curve. Second one, how to draw the load line. Is it clear? Should I repeat this? Okay. After that, you can continue like what you said before. You can calculate our points VDS like the previous one. And this is Argus, it's easy. Now, what is the effect of increase RS of decrease RS? Same thing, decreasing and increasing. Same thing in before. If I increase, it will be like this, go down, increase. And this is decrease. Take care, if I decrease for some point, maybe my line go out. So this is out of working. So take care about RS. This is the issue. Okay, example. Determine the following of one networking of figure 7.1. IDQ, VGSQ, VD, and I guess this is given to me IDSS and VB. So this GFET in channel. How we draw this? I guess now you have to calculate VThevenin, apply VThevenin draw, and find the result that you want. Any question for it? I guess now it's easy. Just numerical implementation. Any question for this? Ahmed, Aryan, anyone? But excuse me, after the lecture, return back and solve by your hand. Easy if you understand with me. Now, common gate configuration is cancelled. 7.251. This is like fixed bias. So this is cancelled. You don't need it in exam. This cancelled. Special case when VGS equals 0. That's mean ID equal IDSS. Now, for depletion type MOSFET, just we will focus on one case. That's mean voltage divider. Because I told you, voltage divider is the common one and the most important one. So we are studying just here the voltage divider. So this is the MOSFET depletion. And what is the difference between GFET and MOSFET depletion? Nothing except, okay, GFET, MOSFET depletion. For GFET, I will draw this. Also, I will draw this. VGS, ID. The only different thing between those, this is in GFET, just we have this part. And to select 4 points, 1, 2, 3, 4 to draw this. For MOSFET depletion, we have 2 parts. This part until here, then I have this part. So if I draw the load line, if I expand the line here, this is مثلا VG, another point will be here, another point will be here. So same thing here, this is Q. Same thing here with this Q. Nothing except if I decrease my line here in this area, but not working. Here, if I decrease by decreasing RS here, for example. Here, decreasing RS or using positive value for VGS. So I will work here. So if you remember, we said this area is GFIT, like GFIT. This area is enhancement. So the only different thing between GFIT and MOSFET depletion, that's in MOSFET depletion we have positive part. In GFIT we don't have. That is, otherwise nothing. All values same, method same. Got the idea? So the only difference between that FIT one can work, the GFIT, just we are working in for example in China and negative part, but for MOSFET depletion we are working in positive part and negative part. So we can say this is from me, can consider MOSFET depletion like Joker. In Joker, you can play in all cases like this one. So MOSFET depletion can work in negative part like GFIT and positive part like MOSFET enhancement. Any question for this comparison? See this here? Same thing, but we have this, take care about this part. I draw to you. Then you can continue use the same formula that I give to you for fixed bias, not fixed bias, excuse me, voltage divider configuration. Same thing exactly. Just in this case, transistor can work in this positive area at enhancement mode. Okay. See, like this case, repeat until R is 170, I decrease. So here we are working in this area, this point in, sorry, we are working at this point here in enhancement. So take care, we have here this area and this area, enhancement mode, GFIT. Is it clear? I guess easy. Okay. Last things for today. I see we are working here about this area for normal area. This circle determine, okay, enhancement type MOSFET. Here we are talking about self-bias cancelled. Another one, this is self-bias, also like self-bias before. We don't change anything. Just we are working at this point. So no problem for this. Just we have the only thing different that mean line can work in positive area. Last thing is enhancement type MOSFET. And here we are using another value, ID equal KVGS minus VGS7, or in your book they sometimes write VT, if you remember. Threshold. If you remember with me, we need time or we need volt until this threshold not working, then start working. So we are working in positive. Where is this I will give you? VT in ID, for example, in one working point working. Example 7.8. Oh, just to check it. Ariane, same what we said before. This is self-bias. You can cancel it. No problem for that. But I did the same, Ariane, that the same thing. But you have to draw and select. Here, for example, see in the theory we start from this area. Here we start from 0. Got the idea? So keep this one, okay, as extra. No problem with this. See, in fix self and voltage. For drawing, also here, for self we start from 0. Voltage will start from this point. Got the idea? So, and only difference that means this curve. Yeah, easy, easy. We just you thought it's so long, but so is easy if you understand the concept for this one. You need just 1 hour to understand it. If you understand this, okay. So easy. Now, last idea today is about enhancement, and enhancement is the enhancement ID VGSQ. So enhancement, you have to calculate K. Where we can find K, I will give you ID on, VGS on, and VGS threshold or VZ. So you have three parameters. You have to calculate K, then you have to draw it. In this one, we don't need feedback. This is cancelled. I don't need this one. Just we need voltage divider. Where's the voltage divider? No, we don't need this. Voltage divider bias arrangement. Same thing. See with me, Ariane. This is same of before. This is same before. So, John, what is the difference? It's difference. That's me in this area. See how to draw this. Here we are calculating VGS exactly, but how to draw this? In this one, okay, this is enhancement. What about depletion? I will draw to you. ID, sorry, VGS. We have this curve, see? This is the first thing. Second thing, load line, VG, same. I need 1 point, select this point, مثلا, this point. Then draw the line, draw the line. This is a Q. This is, for example, Q. Q here, positive, but we maybe we have a Q here as a negative, Q. So here we can find Q in negative, Q in positive. Here just we have Q in positive, and here we have etc. This point V threshold. Before this point, take a diode 0. After that, start working. This is from previous week how we draw transfer curve. Is it hard or easy? Let's read the question area. I didn't read. Okay. So it's the same before. And yeah, it's exactly the same, repeating. But I did ask me, you know how to draw the transfer curve, and after that, how to draw the load line, then it's okay. Same. Any question for this? Ahmed, Ariane? Okay, let's see here. Summary table. In your book, this is concept, by the way. Determine this is concept. We have the summary, very nice summary table. See, GFIT fixed bias, formulas, and the graphical, self bias, configuration, formulas, and graphical, GFIT voltage divider, formulas, and graphical, GFIT common. Get this concept. GFET RD0 special case. This is see this one. After that, MOSFET depletion RD0 also you can ignore it. It's not so important. MOSFET depletion fixed bias. See, focus about this area, Aryan. We have this positive. This is what he asked about fixed bias. This is MOSFET depletion about voltage divider. See the line? Same. Then the last thing is enhancement feedback. We don't need this, cancelled. Last thing, enhancement voltage divider. So our lecture today is easy or hard? Here you have something we don't need this. We don't need those. Just we need last example is which example for you is example number no compensation. We don't need compensation. The last example for you 7.11. Those compensation circuit, okay, cancel it or cancel them. And here those are cancelled. All of these after are cancelled. You don't need. You can read at your home, then you can find summary of this table. Let's try to find some question. Computer is also cancelled. We don't need an exam. Let's go here, for example, fixed bias. We have the circuit and asked me use equation solve. Here for this, it's easy because for chocolate, because we are using a number, but for otherwise, it's referred to as a graphic. And exam, you are responsible for a graphic. For example, each 1 volt equal 1 centimeter, and this is the method for a graphical method. Okay, this for today. Easy or hard?